circuit. Okay, thank you. So MAM School of Engineering, Department of EEE, subject online classes, subject digital logic circuit. Okay, unit number 4, asynchronous sequential circuit. So last class we discussed with asynchronous sequential circuit design. Now we are going to see about our races. So races is a condition is said to exist in the asynchronous sequential circuit when two or more binary state variable changes value in the response to a change in an input variable. Okay, this is a change of two state at a time. This is called races. So races are also classified as non-critical races and critical races. So in the non-critical races means, so in the final stable state, so that the circuit reaches does not depend on the order in which the state variable changed. The race is called a non-critical race. If a circuit whose transition table A starts with the total stable state y1, y2, x is equal to 000, and then change the input from 0 to 1. The state variables must change from 00 to 11, which define a race condition. The possible transition will be 00 to 11 or 00 to 01 as well as 11, then 00 to 10 as well as 11. These are the possible transition for the x value. Okay, so there is a input and output combinations. So critical races. So this races becomes critical if the correct next state is not reached during a state transition. If it is possible to end up in two or more different stable state. So depending on the order in which the state variable change, then it is a critical race for proper operation. So critical races must be avoided. This is the concept because it will define the out. It will change the output in the two and other bits. The below transition table illustrate critical race condition. The transition table start in the stable state y1, y2 and x is equal to 0, 0, and then change the input from 0 to 1. Change the input from 0 to 1. The state variables must then change from 0, 0 to 1, 1. If they change simultaneously, the final total stable state is 111. In the transition table A, if because of unequal propagation delay, y2 changes to 1 because of y1 does not in the circuit. Hence, the race is critical because if circuit goes to different stable state, depend on the order in which the state variables will be changed. So this is the example. So the rounded states are define the possible states to vary. So there is another format available in the asynchronous sequential circuit called cycles. So races can be avoided by directing the circuit through intermediate unstable state. Through the intermediate unstable state with a unique state variable change. So when a circuit goes through a unique sequence of unstable states, it is said to have a cycle. So these are the design of fundamental mode sequential circuits. So draw a state diagram from the given specification of our problem statements. First you have to draw the state diagram. So obtain the primitive table flow table from the state diagram. So reduce the flow table by using the merger graph method. Assign binary state variables to each row of the reduced flow table to obtain the transition table. The procedure of state assignment eliminates any possible critical races. So next step is assign output values to the dashes associated with the unstable states to obtain the output maps. So simplify the Boolean function of the excitation and output variables and draw the logic diagram. So this is the condition number 2. There is a problem 2. The example. So first we are drive the state diagram from the given condition. Then you have to define the primitive flow table, then state reduction, then reduction primitive table. Then you have to define the state assignment, that is 0 and 1 for the particular state transition, then transition table and output map. This is the diagram for next state output. Next one is state assignment. How to define the state assignment in the asynchronous sequential circuit. So it is why we go for state assignment. So for this purpose of using state assignment is to make critical races free circuit. So types: shared row state assignment and one hot state assignment. So shared row state assignment, one extra state, that is shared row in the introduced in the primitive flow table. Okay. So one hot state assignment means in this method only one variable is active or hot for each row in the original flow table. That is, it is required one state variable for each row of the flow table. Additional rows are introduced to provide single variable changes between internal state transition. Okay, these are the state assignment concept used in the asynchronous sequential circuits. So next, memory and programmable logic devices. First we will see the basics of memory unit. So memory unit is a device to which binary information is transferred for storage and from which transformation is retrieved when needed for processing. When data processing takes places, information from memory is transferred to selected register in the processing unit. The memory unit is a collection of cells capable of storing a large quantity of binary information. So communication between memory and its environment is achieved through the data input and output lines and address select lines and the control lines that is specify the direction of transfers. There are two types of memory. One is random access memory, another one is read only memory. So the process of storing the information in the form of digits, in the form of information into the memory is referred as the memory write operation. The process of transferring the stored information out of memory is referred as the read operation. So RAM can perform both read and write operation. ROM can perform only the read operation. So that this means that suitable for binary information is already stored inside the memory and can be retrieved or read at any time. However, that information cannot be altered by writing the concept, writing the information. So basic semiconductor memory array. So each storage element in a memory can retain either a 1 or 0 is called a cell. It is called a cell. So memories are made up of array of cells as illustrated in the below diagram. So each block in the memory array represents the one storage cell and its location can be identified by specifying a row and a column. So it is a 8 cross 8 array. This one is 16 cross 4 array. This one is 64 into 1 array. So depend on the number of cells and the number of row and the column, we can define the memory capacity. The location of the unit of data in a memory array is called its address. For example, the address of a bit in the three-dimensional array is specified by the row and column. The address of the byte is specified by only a row in the two-dimension array. So this is a concept for memory address. The capacity of the memory is the total number of data units that can be stored. For example, in the bit organized memory array, so the first one is 64-bit capacity, second one is 8 bytes, third one will be 64-bit